So today's objective, like I said, is to learn about sine and cosine. So the coordinates of the point of intersection with the terminal side. Yesterday I laid all this groundwork for this, okay? So we talked about where do you normally start? That's on the positive x-axis, right? That's called your initial side. And then you rotate until you get to what's called your terminal side. It terminates there. It stops there, okay? So today we're going to talk about that point that is created, which yesterday I called P of T, remember? T was my angle of rotation, and it created that point. That actually has coordinates of cosine of alpha and sine of alpha. Now, when you look in most textbooks or if you're using online resources, a lot of times they'll list sine first, but I like to be consistent for you, and it makes more sense to me to list your x first and then your y. So you'll notice usually points are written x, y. X comes before y in the alphabet, right? So x is left or right, y is up or down. Cosine C comes before sine S. It's alphabetical, y'all, okay? So cosine is your x coordinate, sine is your y coordinate, all right? So for example, let's just label these so we can review from yesterday. What's the point if I don't rotate at all? So this would be a rotation of 0 degrees or 0 radians. What's the point right there, y'all? 1, 0. Good job. What if I rotate 90 degrees? 0, 1. Good. That's in degrees. What would that be in radians? Need you to be comfortable with either. Pi over 2. Good. If you rotate to here, that's 180 degrees or pi. Okay? What are your coordinates there? Negative 1, 0. Good. And then down here, 270, which is 3 pi over 2, and it's 0, negative 1. Good. So this was 0 degrees, 0 radians, or 2 pi or 360. Okay? Okay, so what I mean by this, if I say, what is the cosine of pi over 2? What I'm saying to you is, what's the x value when you're at pi over 2? Look at it. What is it? 0. So that's your answer. What's the sine of pi over 2? What's the y coordinate? What's the sine of pi over 2? 1. Done. You see how easy that is? Truly, like, don't make it harder. So let's make sure you're good with degrees. What's the cosine of 270 degrees? 0. What's the sine of 270 degrees? Negative 1. And that's it. Questions? Okay, good. So let's just review your new best friend, because we're going to use it. Okay, we're definitely going to use it today. What's the equation for your unit circle? That is what I call best friend, okay? So if I say best friend, I mean, what's the equation of the unit circle? X squared plus y squared equals 1. Okay? It's okay. It's 1 squared, which is 1. Yep, good. And that's because of y. The circle formula, and the unit circle is special because it has a center where? This is the equation because the center is 0, 0 at the origin, and the length of the radius is 1. So that is why that's the equation, okay? Any other circle could have a different center. It could have a different radius length, and so we get a different equation, okay? But the unit circle is special because it's anchored at the origin and only goes out to 1, okay? All right, so from that, we're going to create what's called Pythagorean identity. Sometimes trig teachers just print out this sheet, and it's got these on it, and they're like, here, use these. But I like you to know where they come from so that you can derive them yourself. Just like that equation. You could derive that yourself like we did yesterday in class, right? X minus h squared plus y minus k squared equals r squared, okay? So if you look, Today I told you that x is actually the cosine of the angle, okay? So if I replace this with that knowledge, you can write cosine of the angle. I'm just going to let the angle be alpha. Then it's going to be cosine of alpha, what? Squared. Good. And then it's plus, instead of y, I'm going to plug in sine. And it's sine of the same angle. So sine of alpha squared equals 1. That is a Pythagorean identity, okay? And I'm just going to write this to help you. This is your angle. You can put a t, you can put a beta, you can put a theta, you can put an x, you can put whatever you want. It just means what's your angle of rotation, okay? So that's your Pythagorean identity. All other Pythagorean identities come from that one. All other Pythagorean identities come from that one, okay? I do want to mention, though, just real quick, in case you watch videos online or something, a lot of them put sine first. That's what I was telling you. And they also don't like to have to type parentheses, so they'll write it like this. It means the same thing. The reason why I like this one is I'm a visual learner, and so I like to plug in the value and then square it. Whereas on the second one, it looks like you're squaring sine, doesn't it? But that actually means sine of the angle squared. Okay? So if you prefer that way, I understand what that means, okay? But I prefer to write it this way because I'm visual, and so it cues me in, hey, I got to square this, okay? All right. So the next one, if you want to solve for cosine of alpha squared, if you want to solve that, what would you have to do to sine of alpha squared? You would have to subtract it. So it's 1 minus the quantity sine of alpha squared. That is your second Pythagorean identity. So again, it all comes from that first one, okay? What if you want to solve for sine of alpha squared? What would you have to do with cosine of alpha squared? Subtract it, yep. So 1 minus quantity cosine of alpha squared. You need to know these three. You need to know these three, okay? Now, they all come from which one? The first one. So for those of you that memorize that one, you can derive any other one from it. There's actually a couple more, but I'll get to those later. Okay? Do y'all remember these from Trig? You still have the notes for it? Nice. I had a student a couple years ago. She would actually bring her Algebra 2 binder and her other binders and weave those notes in before my notes so that she could look back at them. I was like, okay, go ahead. She also liked to watch open heart surgery videos. So if you want to become a doctor, you're going to do extra things, right? So that's what that student would do. My point is, if you have those trig notes, if there was something in them that worked for you, you're absolutely welcome to put them in your binder. You know what I mean? They're a reference. It's your notebook. Do what you want to do with it. So, yes?
Go back up to where it says
Thanks for asking. Don't be sorry. It's okay. You good?
Yeah.
Okay. All right. So just real quick, just to review with you, the cosine function is even. That's because it's your x coordinate. I'm not going to spend a lot of time on this, but we talked about the cosine function has, an even function has symmetry, right? But we also talked about if you're trying to determine if a function's even, odd, or neither, you can plug in negative x and see what happens. I'm going to show you. If you rotate an angle, let's say for P of t, right? Where would that be? It would be here, right? So if P of t is here, what are your coordinates when you're there? Positive, positive. Thank you, sir. So if you rotate P of negative t, and you started in the first quadrant, and you rotate to negative t, which is down, you're going to end in which quadrant? Positive, negative. Cosine is your x coordinate. right? Look at your x coordinate there. They're both positive, so that's why it's even, okay? That's why it's even. Sine, it says, is an odd. Well, look, sine is your y coordinate. Look what happened when I plugged in negative t. I went from positive to what? For my sine? Negative. So sine is an odd function, okay? Don't get caught up on that. I'm just referencing prior lessons just to help you see the connection, okay? So if you rotate negatively, it's just going to be an odd function because your sine becomes negative, okay? All right, so special angles in the unit circle. Special angles in the unit circle. So I like to always go back to this one because it's all about having a radius of 1 and a center at 0, 0. We're going to build all of these on that fact, okay? So all special angles are built on this one, all right? So the coordinates when you're here are 1, 0, right? The coordinates when you're here are 0, 1. And we could fill in the rest, but I don't need them for this exercise, so I'm not going to do it, okay? So what do you notice? Yesterday I started laying the foundation for this. I said you cut the semicircle into however many pieces that are listed in the denominator, okay? So that's what we started doing yesterday. So you should be able to tell me what family this is just based on how many pieces I cut the semicircle in. And when I say semicircle, this is a semicircle, right? So this is a semicircle. This is a semicircle. So how many pieces do you have on top and bottom? 4. So this would be 1 pi over 4. This would be 2 pi over 4, but that reduces to pi over 2. This is 3 pi over 4. This is 4 pi over 4, but that reduces to pi. This is 5 pi over 4. 6 pi over 4, but that reduces to 3 pi over 2. And then this is 7 pi over 4. And then we're back to 8 pi over 4, but 8 pi over 4 reduces to 2 pi. So the way you figure out the families is it belongs to the family if it doesn't reduce. So how many of these right here belong to this family? How many? Let's count. Pi over 4, did that reduce? No, so that's part of the family, okay? 2 pi over 4, that reduces, so it's not part of the pi over 4 family. It's actually part of the pi over 2 family, okay? 3 pi over 4 does not reduce, so it belongs to the family. 4 pi over 4, that reduces, so it belongs to the pi over 2 family. 5 pi over 4, and 7 pi over 4. So how many belong to the pi over 4 family? 4. How many belongs to the pi over 2 family? Pi over 2 family, let's look. This was 0 and 2 pi, right? This was pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Do you see the 2 pieces on top and bottom? So how many belong to that family? 4, actually, y'all. 4. I know it's weird because pi reduces and 2 pi reduces, right? But it still belongs to the pi over 2 family, technically, okay? So each family has 4 in the family, okay? 4 in the family. All right, so when you take trig, typically teachers say, here's the unit circle, memorize it. I'm going to give you a quiz every day to see if you can do it in a minute or less. That happens in some classes, okay? I'm not going to do that. If you can do it in the first quadrant, then you should be able to do it in any quadrant because all you have to do is, when you're in the second quadrant, it's negative, positive, negative, negative, positive, positive, right? So instead, if you see where it comes from, you might remember it better, okay? What do you think? Let me zoom in. I'm going to zoom in on quadrant 1, okay? What do you think about if I said connect this point to this point and you connect them, it's going to create a line segment, right? Do you see it? What do you think then if I said connect this new point, pi over 4, to this point? Do you think those line segments are equal? One's bigger than the other? What do you think? They're equal. Why? Don't just take my picture. You can't trust my pictures. I don't draw on the scale normally. It's the side of a triangle. Same angle. Okay. That would work. Pi over 2, and what do we do to it to get pi over 4? Yes, you okay? Okay. What do you do to pi over 2 to get pi over 4? Don't make it harder, y'all. Look. If I drew this, how much of that is this? Half. And then if I drew this, how much of it is it? Well, if you half the bottom part, you gotta half the top, right? We gotta be consistent with fractions. So we went from 1/2 to 1/4. But that's half of a half, yes? So pi over 4 is halfway between 0 and pi over 2. So what does that tell me about these two? Y'all are absolutely right. They are congruent, okay? And when we get to angles, yes, we could have used them. But for now, I'm just going to build it using the line segments, okay? So you learned something valuable way back in chapter 1, if you had forgotten it. The coordinates of this one are, what's the coordinates right here? 1, 0. Do you know the coordinates of pi over 4? No. I'm going to call them x, y, okay? Do you know the coordinates right here at the top? What are they? 0, 1. So if the distance between this one and this one is the same as the distance from this one to this one, let me write that down. The distance are the same. I feel like we've learned something for distance this year. Distance formula. Do you use the distance, dude? Or the formula? The formula? Okay. So can you tell me the distance from here to here? Yes, you can. What does distance formula tell you to do? What does it tell you to do? Subtract the x's. So x minus 1. Okay. Then subtract the y's. Okay. And direction matters. That's why I drew the arrows. Okay. And then do what? Square them. Okay. And then add them. And then last step, square root. But what does it mean if they're the same distance? So from this point to this point, I said is the same distance as this point to this point. What is same? What math symbol represents same? Equal. Okay. So can you tell me now how to get from pi over 4 to pi over 2? What's the distance from here to here? Let me switch colors. Can you find this distance now? What do you do with the x's? Subtract them, yes. So do you want to do 0 minus x or x minus 0? Up to you. X minus 0. I like to go that way too. X minus 0. So I went this way. Okay, so now I'm going to do y minus 1. And then what do we do to those? What do we do to those? Square them. Then we add them. Last step, we square root. And now look, you have an equation now. You have an equation that says the square root of quantity x minus 1 squared plus quantity y minus 0 squared equals square root of quantity x minus 0 squared plus y minus 1 squared. Let's solve it. Both sides are under a radical. How do we get rid of that? Square it. So I'm going to square this side. I'm going to square this side. So when you square a square root, it just falls out, and you're left with x minus 1 squared plus, let's go ahead and simplify that part. What's y minus 0 squared? Y squared, good. Equals, what's x minus 0 squared? X squared plus y minus 1 squared. Okay, I like that better. What's it mean if you have quantity x minus 1 squared? What does that mean? Two of them. It means times itself twice, right? So x minus 1 times x minus 1 plus y squared equals x squared plus y minus 1 times y minus 1, right? Okay. Foil or box method? Box, okay. So here's my scratch paper. I'm going to put it over here. X minus 1 times x minus 1. Okay, x times x is x squared. X times negative 1 is negative x, and negative 1 times negative 1 is 1. So what do we get? X squared minus 2x plus 1 plus y squared equals... What do you think we're going to get when we do y minus 1 times y minus 1? The same thing we just got for x minus 1, except instead of x's, it's going to be y's. Okay? So this is an equation that has x's and y's. Kind of looks like a circle, doesn't it? Yes, because it has x squared and y squared. That's why I said that, right? So typically for circles, we want everything on one side and 0 on the other, right? So I'm going to subtract x squared. I'm going to start trying to move some stuff. But what happens when you subtract x squared? Yep, they cancel. Okay? So nothing really happened, but now they're gone. I'm going to try to subtract y squared from both sides. What happens? It also cancels. Man, this is looking good then. So I get negative 2x plus 1 equals negative 2y plus 1. Okay. How about those ones? You want to try to get those on the same side? Okay. Minus 1, minus 1. What happens? So negative 2x equals negative 2y. Oh, I love it. The face is like, ooh, what is happening? Everything's disappearing, yes? Negative 2x. What are you doing with the negative 2 and the x? You're multiplying. In math class, there's 4 operations. I don't care what level of math you go to, okay? Addition, subtraction, multiplication, division. So when you're solving equations, to move things, you do the opposite, right? So the opposite of multiplication would be division. Okay. What just happened? We got that x equals y. We got that x equals y. Well, good. If I can figure out one of them, what does that tell me? It's the same thing for the other one. How many equations how many variables do you have in this equation? 2. So you should have learned when you have two variables, then you need 2 equations. Okay? What are we working on right now? Special angles in the unit circle. What's my new BFF? Is that for the unit circle? Yeah. Are we working in the unit circle? Yeah, then I can use my best friend. My best friend is the equation, which is x squared plus y squared equals 1. So look what you have right here, though. You now have 2 equations. 1, 2. Those 2 equations have the same variables, okay? So if x equals y, then what can I do with this x over here? I can substitute it in and get x squared plus x squared equals 1. You're absolutely allowed to do that. Because you're in the unit circle, you can use your best friend. That's why I call it best friend, because you're going to hang out a lot. You're going to spend a lot of time together, okay? And now look, you have a new equation that only has x's. X squared plus x squared is? You're not multiplying, you're adding. 2x squared. If you're multiplying, it changes the exponent, okay? It's okay, it's okay. So it's not x to the fourth because that would be multiplication, okay? So if it's addition, you just add the coefficients, but then the exponent doesn't change. If it's multiplication, that's when you add the exponents, okay? That's okay. So 2x squared equals 1. We're trying to solve for x, everybody. What do you do? Divide by 2, okay? X squared equals 1/2. Trying to solve for x, so now we're going to square root, okay? But when you square root, you have to put plus or minus. Ooh, I don't like it. Okay. Can you simplify 1/2? No. Can you split a radical when it's division or multiplication? Yes, that's why we simplify making our little factor trees, right? So this is actually positive or negative square root of 1 divided by the square root of 2. What is the square root of 1? 1 over the square root of 2. Now, look at where I put this, and you can figure out which one it is. Is it positive or is it negative? What quadrant are we in? We're in the positive quadrant, right? We're in quadrant 1, so x is positive. I guarantee you, though, the people in this room that took trig did not learn that the pi over 4 family was 1 over the square root of 2. Which is why in algebra 2, they tell you to rationalize the denominator. When you rationalize the denominator, it means get rid of the radical, okay? So the way that they taught you to do that was how? Multiply top and bottom by that radical, right? What is 1 times the square root of 2? Square root of 2. What is square root of 2 times square root of 2? It's the square root of 2 squared, or square root of 4, which is 2. So if x is square root of 2 over 2, what is y? So you just found the pi over 4 that x is the square root of 2 over 2 and y is the square root of 2 over 2. Those of you that took trig, is that what you learned? You didn't learn that the pi over 4 family is square root of 2 over 2? No? You didn't do nothing like this. Yeah, you didn't derive it, but you didn't learn that family, those were the coordinates? Oh, snap. Okay, well, this is really important, okay? Pi over 4 family has these coordinates, super important, okay? Pi over 4, square root of 2 over 2. What's 2 times 2? 4. Oh, look, how do you think I remember that family when I was in high school? 2 times 2 is 4, and then you just put a square root on the top. Because 2 over 2 would be 1, so you have to have the radical, okay? So, look, we highlighted which ones belong to the family. What belongs to the family when you're in the second quadrant? 1 pi over 4, 2 pi over 4, that reduces. 3 pi over 4, thank you, you're holding up your hand. 4 pi over 4, no, that reduces. 5 pi over 4, that doesn't reduce. 6 pi over 4, reduces. 7 pi over 4, does not. What about 8 pi over 4? It does. You now have all the ones that belong to the family, okay? I don't want you trying to memorize them all. Just recognize you have one in each quadrant, okay? So pi over 4 is in the first quadrant. So 3 pi over 4 is in the second. 5 pi over 4 is in the third. 7 pi over 4 is in the fourth. What are your signs when you're in the second quadrant? Negative, positive. So it's going to be negative square root of 2 over 2, positive square root of 2 over 2. What are your signs when you're in the third? They're what? Negative, negative. So all you got to do is negate them both. Okay? What about the fourth quadrant? Positive, negative. Questions for me? Yes. Sure. So you just derived the pi over 4 family. Did it make sense? Yes? We just used distance formula, which I taught you in chapter 1. Because it's halfway between 0 and pi over 2, they have to be the same distance, okay? And then once we got it down to here, that's when you had to bring in your new best friend because you had 2 variables, which means you need 2 equations, okay? That's going to be super helpful in this chapter, so I'm going to say it one more time. When you have 2 variables, you need 2 equations so that you can isolate one variable, okay? You would have got the exact same answer if you had plugged in y for x squared instead of me plugging in x for y squared. It doesn't matter, okay? You'll get the same, you would have got the same answer because x equals y. So it doesn't matter, okay? All right, we're going to do another one. I'm starting to lose some of you. So I would like you to just stretch, wake up, come on, stay with me. It's whose? Oh. Are you? What didn't make any sense? Oh. Oh, sorry. Okay. What family are we getting ready to work with? Don't look at the bottom. Look at the semicircle. 3. So this is going to be 1 pi over 3, 2 pi over 3, 3 pi over 3, but that reduces to pi, 4 pi over 3, 5 pi over 3, 6 pi over 3, but 6 pi over 3 is 2 pi. So which ones actually belong to the family? Good. I want y'all to talk about math. When you talk about it, that is engaging. So it's good. Say it. And I don't care that y'all weren't matching up. Some people were going around the circle. Some people were on the top and then the bottom. I don't care. There's 4, right? So down here, I can go ahead and write those in my little pi over 3 family. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, If it reduces, it's not in this family. That rule does not apply to the pi over 2 family, but it applies to pi over 6, pi over 3, pi over 4, okay? Oh, one more thing. Did I say memorize all 4 of those? No, what'd I say to you? Just memorize which one, sir? The first one. Why? Why? Why is that the only one that really matters? Because the sign changes in each quadrant. Do the values change? No. So don't waste that energy. Y'all got all kinds of classes. I respect that, okay? I know this is not your only class. So just learn the first one, okay? So on this one, which one do you think you're going to need to know? The pi over 3, right? Pi over 3. And then you can just walk around the circle to figure out the other ones, right? Negate where you need to, okay? All right? Okay. Don't worry. This is the last derivation I'm going to do, and then we'll move on. I'll just tell you what the last one is, okay? All right. So for this one, you'll notice one of the axes is missing. So if you look here, you have the x-axis, right? Then you have the y-axis. You know the coordinates. Hello. I don't have a question. Go away. Okay. You know the coordinates when you're here, right? You know the coordinates here, but is that axis even drawn over there? No, I removed it because it sometimes can confuse people, okay? So it's there. We just don't have it drawn in, but I don't need it, okay? So if you're here, what are the coordinates when you're here? 1, 0, okay? If you're at pi over 3, what quadrant are you in? The first quadrant. So I'm ignoring the fact that some of you have had trig. We don't know this coordinate because we haven't derived it. So I'm just going to call this x and y. Okay? Now, what do you think if you're splitting it into thirds? What do you think about the distance from this point to this point versus the distance from this point to this point? They should be the same distance, right? Because it's a 3, it's a third, right? 1 pi over 3, 2 pi over 3, 3 pi over 3. But a while ago we used 1, 0, and then 0, 1. But that axis isn't even drawn right now. So if you're in the first quadrant, it's positive xy. What quadrant are you in if you're at 2 pi over 3? Second, it's negative. Say it. Do it. It's negative. Then it's positive. So if they're the same distance, it's the same family, I can just negate the x, but it's still going to have the same y, okay, because it's the same family. What do you think we're going to do? I know, you love this so much. I love it so much. Come on, y'all. We're doing math. It's fun. Come on. We're going to find the distance from this point to this point, and we're going to set it
0.
no equal to the distance from this point to this point, because they're the same. It's the pi over 3 family. They're the same distance. Okay, so you want to do 1 minus x or x minus 1? Okay, so we're going to go this direction, x minus 1. Then we're going to subtract the y's, so y minus 0. Then what do we do? Square. Distance, dude, y'all. Subtract. Then you square. Then you add. Then you square root. So square. Now we thank you. Add. And last step, square root. So I just did this one over here. Now I'm going to do this one. You want to do negative x minus x or x minus negative x? Which direction you want to go? X plus x. So this way. So she said x plus because minus the negative makes it addition. So x minus negative x. So now I'm going to have y minus y. Then I square, then I add, then I square root. And because they're in the pi over 3 family, they need to be the same distance. Same in math class is equal. Okay? Well, you should know from the last one, the first step is to get rid of the radicals. So we're going to square both sides, okay? X minus 1 squared plus y minus 0, but y minus 0 is just y squared. Good. X minus negative x. Minus the negative is plus. Good. So you get x plus x. X plus x is 2x, thank you. And then we're going to square that. And then y minus y is 0. 0 squared is 0. So it's gone, right? It's gone. Okay. I'm going to pause and let you try to finish it. Let's see what you got. Oh, dear.
Guess what Miss King told us?
No idea.
That in some state, this teacher was looking away, and these students were like killing
Sure.
themselves, and then the school had got like sued or something
Oh.
because they actually.
You got it. Do it.
Will you square 2x and not 4 squared into a square? parentheses on it. Like up there, she wrote the 2x parentheses, and she squared it. So is that 4x squared? Or is it not 4x squared? Yeah, we can tell. Yeah, they're playing.
No, it's not.
On the cheese list.
You can ask me something.
See, did you get it?
I got confused. I got in the box thingy, so I'm good. I'm saying yeah, like I'm confused when
We're stuck. Now we're stuck too.
Yeah.
All right, then that wasn't wrong. She's cooked, bro.
I thought I had it yesterday. I had to take this. Jasmine, why are you doing this? What? What time is it?
read the clock.
11:33.
And now you have all that. Okay.
You was close.
All right, y'all, this one's a little bit harder, so it's okay. You're good. I just wanted you to try it. It's good for you to try things, but it's nice to have a friend. I'm in the room, so I got your back. Don't worry. I just wanted you to try it. Okay. So if you look, hopefully when you foiled this or box method, you good, friend? You good? Yeah? Okay. So you get x squared minus 2x plus 1, yeah? See, bueno. And then you get 4x squared on this side? Yes, okay. So I see x squared, y squared, but I see everything's on different sides, right? So actually, instead of moving the 4x squared over, I actually moved everything to that side so that the x would be positive. You don't have to do it. This is just my preference. So I subtracted x squared. And 4x squared minus 1x squared is 3x squared. And then I added 2x. Are you okay with what I'm doing? The opposite of subtract is add, right? You're okay, I promise, friend. Take some breaths. Take some breaths. In your nose, out your mouth. It's okay, everybody. Okay. And then the opposite of plus 1 would be?
Minus.
Minus. And then the opposite of positive y squared would be?
Negative.
Negative. And that equals 0. Okay? Don't freak out. Don't freak out. Let's zoom in and focus now. Everything's on one side. But the issue is I have x, constant, y. How many variables do you have? 2 variables. X and y. Y'all, just because this is x to the second power and x to the first power, that's still an x. So, okay, so that's just one variable. And then you have a y. So 2 variables. So a while ago I said it. When you have 2 variables, you need 2 equations. Okay? So what am I getting ready to call on? Best friend, thank you, Jesus. We're going to call on the unit circle, but that's okay. I like it. So, best friend, okay? That's why I call it that, because you got to remember it. You've got to remember it so that you can use it when you need it, okay? What's best friend? X squared plus y squared equals 1. Now, let's look at these two, okay? If you solve this for x squared, everybody just watch. Don't write for a second once you've written all this. Let me let everybody get caught up. Okay. If you solve this for x squared, that would be the Pythagorean identity I just taught you, right? Just watch. Don't write anything. So if you plug this in for x squared, you would have 3 times quantity, 1 minus y squared, plus 2x minus 1 minus y squared. Did that help me? No, look, I got y's, I got x's, I got y's. That doesn't help me, right? So I'm not going to do that. That doesn't help me. I'm not going to do that. So instead of solving for x squared, what if I solve for y squared? What would I do to solve that for y squared? Subtract x squared from both sides. And you get y squared equals 1 minus x squared. What happens if I plug all of that in for y squared? Let's look. I would get 0 equals 3x squared plus 2x minus 1 minus quantity. Notice I'm putting it in parentheses. 1 minus x squared. Now look. What do you notice? Now there's only one variable. I've got x squared, x squared. I've only got one variable now. Okay? I show you that because a lot of times when I do things, you're like, oh yeah, I got it. Makes sense. But then you go home and you try it on practice problems, or you wait and then you try it on a quiz and you plug in the wrong one and you're like, I got 2 variables. I don't know what to do. It means you need to stop, solve for the other variable, plug that in. Okay? Everybody good? You understand why I solved for y squared instead of solving for x squared? Okay. Well, now it's all in terms of x. So first step, I'm going to distribute that negative. So I get 3x squared plus 2x minus 1 plus x squared. Combine like terms. So you have an x squared here, an x squared here. You have a -1 and a -1. So 3x squared plus 1x squared. 4x squared plus 2x minus 2. That's a quadratic. I've been working with you on quadratics since chapter 1. Right? 3 options. But first step, always look to see, can you factor out a GCF? Is there a GCF? Yes. What is it? Dose. 2. So when you factor out the 2, you get 2x squared plus x minus 1. Thank you. This class makes me work for it. Y'all won't say things out loud. I have to read your mouths. Like it. Yes. Yes. Thank you. Okay. Now what? If you set each factor equal to 0, you have a leading coefficient greater than 1. So I've taught you to slide and divide. A lot of you tried using the quadratic formula. You can also do that. You have an A, a B, and a C. I'm going to try slide and divide, though, because I just really love to factor. Slide and divide. Okay? So that would be x squared plus x minus 2 equals 0. Can you multiply to get a -2, but then add to get a +1? Yes, what? 2 and -1. But 2 plus -1 is 1. Yeah, I agree. So this will be x plus 2, x minus 1. But we slid it. Now we got to divide it. So I'm going to divide by the 2 because that's what I slid. And I get x plus 1, 2x minus 1 equals 0. X plus 1 equals 0 gives me x equals -1. 2x minus 1 equals 0 gives me 2x equals 1. So x equals 1/2. Don't get mad. You're all right. How many answers did you just get? 2. Is that okay for a quadratic, like if we were working with quadratics? Yeah, totally fine. But look at what we're working with, yes? Let's look. I am working with the unit circle. I'm trying to find this x right here. I'm trying to find this x right here, right? Because that's xy. Yes? Look at your 2 answers. You got 1/2 and you got -1. What family are we in?
You said what?
I said, what family are we in? We're in the pi/3 family. Only one of those answers makes sense. 1/2 or -1. Don't I have a family that has an x coordinate of -1? Isn't that the pi/2 family? Pi/2, pi, 3 pi/2, 2 pi, right? So can you get -1 for this value right here? No, that makes no sense. So sometimes you got to look at your answer choices and your answers and see, does that actually make sense? Oh, that doesn't make any sense. So you just found the x coordinate. It's 1/2. The x coordinate for the pi/3 family is 1/2. So now you know the x. Can you find the y? Yes, it's called back substitution, okay? You can either plug into this up here to solve for y, or you can just plug into best friend over here because that only has 1x, and you've already solved for y, right? Do you see what I'm saying? Let me highlight it for you. I'm going to plug in right here to solve this for y now, okay? Let me write it down here so you can see. So I'm going to have y squared equals 1 minus quantity 1/2 squared. It's called back substitution. You should have learned earlier how to solve equations, okay? How to solve systems of equations in a previous class, all right? And then we've done it a little bit in here. May God bless you. Woo! What is 1/2 squared? 1/2 times 1/2. Scratch paper. 1/2 times 1/2. 1/4, yes. It's not 1/8, y'all. 1/4. Okay, now we have 1 minus 1/4. It's okay. I'm glad you're talking to me. It's okay. Nothing happens if you're wrong. It's all right. 1 minus 1/4? 3/4. Good. How do you isolate y if it's y squared? You square root. So y equals positive or negative square root of 3/4.
Until we have space in my paper.
You do? Oh, sorry. It's positive because you're in what quadrant, friend? First. Good. And also, does it benefit me to split this radical? Yeah. So I'm going to put square root of 3 over square root of 4. Everybody hear him? He said it's positive, and I said why? He said because we're in the first quadrant. Square root of 3 is the square root of 3. Square root of 4? 2. So for those people that took trig, you would have learned that the pi/3 family has coordinates 1/2 square root of 3 over 2. For everybody else that's not had trig, do you understand why it has those coordinates? Yes? Okay, good. I'm going to write square root of 3 over 2. Remember, that's the only one you have to memorize. Now just take a walk around the unit circle. So when you're at pi/3, that's in which quadrant? That's in the first. So this one's going to be in the second. This one's in the third. This one's in the fourth. So all you got to do is do what to those x's and y's? Change the sign. So when you're in the second quadrant, it's negative, positive. When you're in the third quadrant, it's negative, negative. And when you're in the fourth quadrant, it's positive, negative.
Anytime you take a while to say negative, I think you're negative.
Me singing the quadratic formula? Okay, we're not going to derive the last one. It's okay. I'm glad that song helps you. That's why I do it. You're good. All right, y'all. I'm not going to derive pi over 6 because I would like to move on to cosine and sine. But the reason why I just took all this time, you could tell me the cosine of pi over 3. Everybody, right now, what is the cosine of pi over 3? What is the cosine of pi over 3? 1/2. There we go. What is the sine of pi over 3? Okay, so see how that works? Good. I am going to tell you these, and then I'll tell you my little trick, because I want you to have to write them all every time, okay? Pi over 6 family, let's look. That means you're cutting the semicircle into 6 pieces. Okay, so this is 0, pi over 6, 2 pi over 6, but what is 2 pi over 6? It's 1/3. It's pi over 3. Then 3 pi over 6, which is 1/2. So pi over 2. Then 4 pi over 6, 2 pi over 3. Then 5 pi over 6. Then 6 pi over 6, which is just pi. Then 7 pi over 6. 8 pi over 6, but 8 pi over 6 is 4 pi over 3. I wrote too big. Then 9 pi over 6, but 9 pi over 6 is 3 pi over 2. Then 10 pi over 6. I know everybody doesn't have a master's degree in math. I'm just simplifying fractions. You're okay. Then 11 pi over 6, and then 12 pi over 6.
It's stuck in my head. I can't get it out.
All right. It doesn't belong to the family if it reduces. That only applies, though, to all the families except pi over 2. So let's highlight which ones actually belong to the family. Pi over 6. 5 pi over 6, 7 pi over 6, 11 pi over 6. Good. And I'm going to give you these coordinates. Okay. Pi over 6 family is the same as the pi over 3 family. You just switch the x's and y's. So it's literally the square root of 3 over 2, comma, 1/2. It's the exact same coordinates. You just switch them. So that's in the first quadrant. So what do we do if we're in the second quadrant? What are your signs? Negative, positive. What about the third quadrant? Negative, negative. Fourth quadrant. Positive, negative. Don't worry, I got your back. I'm getting ready to show you something really helpful that if you'll write this on the top of your paper, you'll be good. Okay? Because all of y'all are like, oh my gosh, am I going to have to do this every time? No, you're not. Which one's the smallest? Hold on, and then I'll go back. Which one's the smallest? Pi over 4, pi over 3, or pi over 6? Pi over 6. Okay, then which one's smaller? Pi over 4 or pi over 3? Pi over 4. So the biggest one is pi over 3. These are in order, smallest to biggest, in the first quadrant. That's the only one I want you to focus on, because then just negate when you need to. Make it a negative. That's all you got to do, okay? Depending on which quadrant you're in, all right? Watch. 3, 2, 1. 1, 2, 3. 3, 2, 1. 1, 2, 3. Did everybody see me do that? 3, 2, 1. 1, 2, 3. Okay, they're all over 2. And then you just square root when you need to. And I know which ones I need to. Can 3 halves be on the unit circle if it has a radius of 1? No, that's bigger than 1. It's 1 1/2. Ah, that must be square root of 3. How about 2 over 2? What is 2 divided by 2? 1. That's the pi over 2 family, yeah? Ah, that's got to be square root of 2 over 2. Is 1/2 okay? Yes, because the radius is 1. 1/2 is less than that, so that's okay. Okay, there you go. 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. I gotta bring the enthusiasm because y'all are not. Y'all are tired. We're okay. I actually learned that first semester from a student. You're glad you didn't learn that in trig? Why? It's too much to learn the math.
Once our street teacher found out that my class, like my class was cheating,
Uh-huh. Oh.
And he had like a British accent, so it was like hilarious when he was mad. When he got mad, but it was like,
Oh.
because we had to stop his practice.
Oh.
It was 6.
Oh.
And now he don't like nobody respect me.
Everybody? Everybody? Those are the coordinates, and you just have to make them negative depending on where you are in the unit circle, okay? Don't pack up. I have 4 minutes, so stop packing up. I don't know what y'all are doing. I have 4 minutes. That's a long time to do math. All right.
I don't think Tim wants to do any more minutes.
That's okay. He's going to power through. I know his personality. Okay. So, yes, he will. He will. You will too. Okay. I used to think of it 3 times 2 is 6. 2 plus 2 is 4. 1 plus 2 is 3. That's what I came up with when I was a high school student. Do whatever works for you. Miss Whitaker shows them a finger trick, like pi over 6 is 3 over, I don't know. I can't do it. She'll show you next year in calculus. So if that works for you, go see her. She can tell you. I just learned the 3, 2, 1, 1, 2, 3. Makes sense to me. All right. So let's find the reference number. Reference number is the shortest distance. I actually might skip these just so I can get to more of the cosine sine ones. There we go. I like these. So it says use the reference number, so I'll kind of teach it as I go. So the angle is 2 pi over 3. So what family are you in? Pi over 3. That's your reference number. So automatically your brain should be thinking of those things I just wrote down for you. So let's write them down up here. Smallest is pi over 6. Next smallest is pi over 4. Biggest in quadrant 1 is pi over 3. 3, 2, 1. 1, 2, 3. They're all over what number? 2. And then who do you square root?
3.
The 3s and the 2s. Good. So, where is 2 pi over 3? What quadrant is that in? The reference number is pi over 3, so that tells me I'm automatically going to have 1/2 and square root of 3 over 2. Okay? But I think I got to figure out what quadrant I'm in to see if they're positive or negative. So, cut the top of the circle into 3. Cut the bottom of the circle into 3. This would be 1 pi over 3, 2 pi over 3. I'm in which quadrant? Second. So the cosine of 2 pi over 3 is negative, and look at what you wrote up there. It's negative what? 1/2. And the sine of 2 pi over 3, if you're in quadrant 2, it's positive. So it's just square root of 3 over 2. You got it? Good. I'll let you pack up. Have a good day, everybody.